Okay, so we're going to have a look at some of our maths. So we're just looking at the back page of our arithmetic paper for today. We're going to go through some of these questions. For ones like this, where you're multiplying a fraction by a fraction, you simply need to multiply the top by the top and multiply the bottom by the bottom. Okay, the way that works in practice is because this is asking you for 1/4 times 1/2. We know with fractions, if we have a multiply of a fraction, that can mean the same as of. Okay, so it's a half of a quarter. So if I imagined me having quarters here, and it's then saying, well, I want you to do a half of that quarter, what I'm going to need to do is I'm going to need to take those quarters, I'm going to need to split them in half. So I've got half of a quarter, which is just going to give me here 1/8, because I have 8 equal parts now, which is the same as doing the top times the top multiplied by and the bottom times the bottom. So I do 1 times 1, which is 1, and I do 4 multiplied by 2, which is 8. Okay, so a quarter times a half is 1/8. For the next calculation here, I have 0.1 is question mark over 50. We've seen some of these recently, which we've been looking at. So if I just fill that bit in there, we're just going to ignore that first of all. I know I'm turning a decimal into a fraction, so I'm going to turn this into something that I know first of all. So I have my 0.1, I'm going to turn that into something I know, which is actually 1/10. Okay, now I know I've got that as a fraction. I can look at what I want it to be. So what I have here is I need to have my tenths in 50ths. Okay, it needs to be an equivalent fraction. So I need to then look at this, I need to inspect the bottom here. How do I get from 10s to 50ths? Well, what I'm doing there is I'm multiplying by 5. 10 times 5 is 50. If I've done that to the bottom, it means I have to do that to the top. So I need to do 1 multiplied by 5. I'm doing the same thing to the top as I'm doing to the bottom. Okay, because it is an equivalent fraction, it is the same. I'm telling you what 0.1 as a fraction is as a fraction out of 50. So 1 multiplied by 5 is 5. So 0.1 is 5/50ths. Question 24 today, we have 2,825 multiplied by 26. Okay, the big thing with this one, the reason that we get these wrong is because we forget the placeholder when we're multiplying through. Okay, fairly straightforward. Knowledge of your calculations, knowledge of your times tables, you should be able to do this with relative ease. Okay, so we're going to start, we're going to do 6 multiplied by 5, which is going to give us 30, so I'm going to put the 0 down, I'm going to carry the 3. I then have 6 multiplied by 2 tens, which is going to give me 12 tens, plus my 3 tens gives me 15 here, 15 tens. Then I have 6 multiplied by 8, which is going to give me 48 hundredths, plus my 100 here is going to give me 49 hundredths. Okay, then I have 6 multiplied by 2 thousands. So 6 times 2 is 12, so that's going to be 12 thousandths. Plus my 4 is going to give me 16 thousandths there. Okay, now I've done that part and I've carried all of these up into the next part. So I can have a think about what the next element of my calculation is here. So if I just pop a little dotted line underneath that, this is where we make the mistake. This is the thing that we forget. The thing that we forget is popping in the placeholder. I have to put the placeholder in here because I'm not now multiplying by 2. This is multiplying by 20, and because it's multiplying by 20 and not by 2, it's 10 times bigger, which is where my placeholder comes in. Because if I put a 0 in there, it pushes everything else along one column, which is the same as multiplying everything else by 10, making everything 10 times bigger, which means I can then simply just multiply through by 2. Okay, so I'm going to have 2 times 5, which is going to give me 10. Okay, and then I've got 2 multiplied by 2, which is 4, plus my 1 gives me 5. And I have 2 multiplied by 8, which gives me 16. And then I have 2 multiplied by 2, which gives me 4, plus my 1 gives me 5. Okay, then I've got all of these in here, and I can, if I move my arrows out of my way, I can then work this through here. Okay, and then it's as straightforward as adding these two up now. Okay, so I have my 0 plus 0 is 0, 5 plus 0 is 5 tens, 9 hundreds plus 5 hundreds is 14 hundreds, carry the 1 down, 6,000s plus 6,000 plus 1,000 is going to give me 13,000, and then I have 10,000 plus 50,000 plus 10,000 is going to give me 70,000. Okay, so that should give me my answer there of 73,450. I think that's correct. I have then this one, which is another one to the one we had similarly earlier. Okay, where we have our percentage, but this time percentage as a fraction. If I cover that one up here, okay, I have 96%. I know I need that as a fraction, so I'm just going to first of all write that down as a fraction that I can. We know that any percentage is out of 100, so I have 96 out of 100. Okay, so now I have my percentage as a fraction, I can look at how I need to make that equivalent. So I need that in 25ths, not in hundredths. So if I think about what happens between those 2 points, how do I get from hundredths to 25ths? Well, 100 divided by 4 is 25. And if I've done that to the bottom, to my denominator, I have to do that to my numerator. So I have to take my 96 and I have to divide that by 4. Okay, you can work that through with your times tables, or if you're a bit wobbly on that, you can pop that into a short division method. And you can work that one through there and get the answer of 24. So you have your answer of 24 25ths. There's also another thing to spot here. You're dividing by 4. 96 is 4 less than 100, so that when you change that up, that's going to be that 4 you're going to divide by 4, which is going to give you a difference of 1 over here. Okay, which is 24 over 25. Question number 26 is 3 1/3 plus 1 2/9. This is going to be needs a little bit of work because 2/9 and 1/3 are obviously in different denominations here. Okay, so what I need to do is I need to spot that I can turn a third into a ninth quite easily. Okay, so what I need to do is I need to make a third equivalent to a ninth as a fraction. Okay, and in order to do that, so I have 1/3, and how am I going to get that to ninths? Well, if I think about what I'm doing there, 3 to 9 is multiplied by 3, which means I have to do the same to the top. I have to do the same to the numerator. I have to do 1 multiplied by 3, which is going to give me 3/9. Okay, so now I can rewrite my calculation as 3 and 3/9 plus 1 and 2/9. And now, because my denominators are the same, I can just add them straightforward. Okay, and what I can spot here is if I look at these two here, I have 3/9 and 2/9. I know that 3 plus 2 is 5, which is less than 9, which means that 3/9 plus 2/9 is going to be less than 1 whole, which means I can separate out my calculation. So I can simply do 3 plus 2 equals 5, and then I have 3/9 plus 2/9 equals 5/9. So my answer here is going to be these two recombined, which is going to give me 5 and 5/9. A couple more here, then we have question 27. Similar but different to the last one. Okay, again I have denominators that are different, and I need to make them the same. I need to make my denominators the same so I can add them. Now 3 and 7 will not, so 3's don't go into 7 times table. We should know that as well because both of these numbers are prime. So I'm going to have to find a common multiple. The easiest way to find a common multiple of both 3 and 7 is to multiply them together. So 3 multiplied by 7 equals 21, which means that if I turn both of these fractions into 21ths, I can make both denominators the same, which means I can add them quite easily. So I need to make a third into 21s. Okay, And in order to do that, I multiply the denominator by 7, which means I need to multiply the numerator by 7 as well. 1 times 7 gives me 7. So now I have 7 21ths. But at the moment I'm trying to add 7 21ths to 3 sevenths, which isn't going to work. Okay, so I need to make my sevenths into 21ths as well. So if we do that, let's use a different colour for that. Let's do 3 sevenths. We want 3 sevenths in 21ths. So I'm going to look at my denominator and I'm going to say, okay, well, to get from 7 to 21, I need to multiply by 3. And if I'm multiplying the denominator by 3, it means I need to multiply the numerator by 3. So I can pop that in there. And then if I look at that, 3 times 3 is 9. So now if I rewrite my calculation, I have 7 21s, and I'm now adding 9 21s here. Okay, so I've got 7 21s plus 9 21s, which is going to give me my answer of 16 21s. Okay. Finally, we have 2 3/4 multiplied by 3. This question is going to be slightly trickier because I can already look at this and I can already say, well, if I have 3 lots of 3/4, that's going to be greater than 1. If it's going to be greater than 1, this is where I need to be careful, because if I just separate this and multiply them through, I'll get an answer that gives me 6 9/4, and I can't have an answer of 6 9/4 because 9/4 is an improper fraction. Numerator is greater than the denominator, which means it's greater than 1. So I can't have 6 and greater than 1 as a number. It just doesn't work. So what I can do is I can split this off and I can deal with this in 2 separate parts. I can have 2 times 3, and I can have 2 times, I can have, not 2, I can have 3/4 times 3 as well. Okay, so let's deal with these two separately. The first one's very easy, very straightforward. 2 times 3 is 6. So I can leave that alone. I can park that until later. We'll come back to it. This one is slightly trickier. 3/4 multiplied by 3. Well, if you just multiply them straight through, I'm going to wind up with 9/4. 3 times 3 is 9. So 3/4, 3 lots of 3/4 is going to give me 9/4. But then what I need to do is I need to turn this from an improper fraction, where the numerator is greater than the denominator, into a proper fraction, or a mixed number fraction, as it will be because it's greater than 1. Now, what this is essentially telling me is I have 9/4. So if we imagined it like this, and I had a shape here, or I had bars here representing my holes, and I split my holes into quarters, in one hole I would have 4/4, but I've got 9/4. So in 2 holes I would have 8/4, but I've got 9/4, so I need 1 more. So what this is telling me is that 9/4 is actually the same as 1 hole, 2 hole, and 1/4. So 2 1/4 is the same as 9/4. Okay, 4/4 in a hole, 9/4 is 2 1/4, which then means I have my 2 elements I can put back together now. I have 6 plus 2 1/4, which is simply going to give me 8 1/4.